All right, let's do this. So it's leaking test cases time. So let's talk about test cases for task 3. These typically, just the way things have been going or whatever, these, or maybe it just makes sense for these to be on Friday. So like every Friday, I've been leaking test cases. So task 3, let's talk about test cases. So there are a few things to worry about with task 3 testing, and let's talk about each one of them. Let's do an example in Go for 116. No, thanks. So let's talk about the add ratings. I'll show a test case for add ratings. I have a song. Bam, song. It's got one song rating. And I want to add a rating. So we're going to call this add rating with a new rating with a different rating and energy level. And since song is immutable, I expect this to return a brand new instance of a song with that new rating added to it. What I expect after that rating has been added, my expected song is going to contain both of those ratings. Nothing mind-blowing there. But I'm expecting a song with the same title, the same artist, the same YouTube ID, but both of those ratings, the rating from the original song plus the rating that was added. So far, the test case is pretty straightforward. The big trick, I guess, I don't know if it's a trick or just something to think about, is that there are going to be two possible correct solutions in this example. So I'm calling it a compare songs method here. We'll scroll up to that in a second. I didn't write the whole thing because I don't want to give everything away. But there are two possible correct solutions at this point. The song with both the ratings and the song with both the ratings in the other order. So the song rating, the add rating method or add ratings, there's nothing that says anything about the order of the ratings. The ordering is completely undefined, it's completely arbitrary. We don't care about the ordering at all in our code. So when you're testing, you need to accept every possible ordering of these values. So you have two song ratings, so there's two possible solutions that you need to accept. If we had 3 song ratings, there are 4 possible, that's not right, 6, it should be, right? 6 possible solutions that are correct. Any ordering of those 3 elements, 4, and then some number I can't even comprehend right now. Some crazy number. But anyway, you need to accept any order of these ratings. So if we're prepending or appending, both of those would be correct. Or even if some correct solution wants to take the new rating and jam it right in the middle of the list, that's still valid. They added the rating to the song, and that should be marked as a correct solution. I'm not doing anything crazy in AutoLab like that, but that would be accepted. That should be accepted as a correct solution. So as you getting marked a correct solution as incorrect, and you're looking at your tests, and the TA looks at your tests, and everything looks fine, make sure you're checking the ordering of these and making sure you're accepting any ordering of the song ratings. So in our compare songs, I like, especially for this one, I really like having a helper method. In my compare songs method, just like I like having a compare doubles method as a separate method, I really like a compare songs method because there's going to be quite a bit of logic in here to be able to compare, are these two songs the same, equivalent enough for my test case? I'm going to want to call this method and have this logic many, many times in my test cases. Every time I need to say, are these two songs effectively equal according to my test? So every time I do that, I don't want to be cut and pasting code and swapping variable names and all kinds of mess. I don't want to do any of that. So if I write a method that compares 2 songs for me, then every time I need to compare 2 songs, I'm just going to call the method. Same thing I said when we talked about compare doubles. I like that as a helper method. I'm just going to call that method whenever I need to compare 2 doubles. I write that method once, and then I never think about epsilon again. I don't have to think about it anymore because it's just in that method. So with compare songs, it takes 2 songs. The first bit, you should all be able to figure out. You got to check the YouTube ID, the artist, the title. That's pretty straightforward. Make sure they have the same number of ratings. If they don't have the same number of ratings, they're not the same song, according to our tests. And then after that, that's where I'll leave it up to you. But after that, we need to check if the list of ratings in each song contains ratings with the same rating and energy level in any order. So this is a flashback to comparing lists. Way back in LO1, we had to test a method that returned a list, and the order didn't matter. Way back in LO1, we just did dot sorted, done. Just dot sorted, we don't have to think about it too much. Now we got to think about this a little bit more because we have a custom class that we're sorting. A custom class that has no default comparator, has no way to compare two elements of this type, and we have no way to check for equality between two elements of this type. And we need both of those things here. So my recommendation for this, it's the example we had, roughly the example we have in the test. My suggestion for this, sort the list still. You can't just do dot sorted, but we talked about sorting for like a week. You know all about custom comparators and all that stuff. So find some way to sort these things in a deterministic order. And keep in mind that if you're sorting like just on rating, if you're sorting on ratings, two song ratings with the same rating could have different energy levels, and those would not be the same rating. So some deterministic way to incorporate both these values, rating and energy level, sort them in a deterministic way. So if you have two lists of song ratings, no matter what order they start in, if you use your custom comparator, they will both end up with the same exact ordering, no matter what any of the values are. If two elements are in different orders in the two lists, that only can mean that they have both the same rating and the same energy level. That's the only way that that can happen. And if that's the case, then we treat those as the same rating anyway. So sort them. And then we still can't just do equal equal on the list. Equal equal on the list assumes that we have a way to check if two elements are equal. Now we could think about overriding the equals method in the song rating class. There's just one problem, is that code would go into your solution, and when your tests are ran against different solutions, that equals method, that overridden equals method, will not exist. So unfortunately, we don't have quite that option. Well, we kind of do, but you'd have to write that equals method in your tests as a helper method. We could do that. But so we can't really do that. What we're left with is the old-fashioned way. Iterate through the ratings of each song. So you have two lists. Do what the equals method does for lists and iterate through them, index 1, or index 0, index 1, index 2, index 3, and go step by step through each list and make sure they each contain the same rating and energy level for each index in the list after sorting. So that's my recommended approach. If you want to do this some other way, be my guest. You can, any way that you can check to see if these two lists have the same rating and energy levels across all the ratings in any order. That's the problem that you need a solution to. This is my recommended solution. In fact, it's the way that I did it in my tests that are in Autolab. So that's my recommendation for that. Yeah, no thanks. So any questions on testing the add ratings method? Like this is a case where the method itself, there's not a whole lot of work to do. Where you're learning things and where you're getting practice is with the test cases. So I want to make sure you understand what the task is for writing this method and for the add ratings. Once you have this method set up, add ratings is the same thing for the test cases. You just call your helper method. But any questions on this? All right, moving on then. So we also need to test this list, song list to map. Is that what it's called? Song list to map method. So we need a list of songs. I have a list with just one song here. I'll explain the ideas of the testing, and then you can extrapolate that to multiple songs and multiple songs with the same YouTube ID, things like that. But here I just have one song. We might have duplicates in here. Your list here should be the should be the output of your task 2 code. So you have that read, that really long, ridiculous named method, read songs from file without duplicates. In that method, the file might have duplicates in it, so your list might have the same song multiple times with different ratings, but you don't care about that in task 2 because we're going to fix it right here. In this task, you're going to take in a list of songs that will be in the same format as your output of that method from task 2, and then you're going to fix that problem of we didn't handle duplicates. We didn't do anything with duplicates. Here's where we're going to take the fact that this list might have duplicate songs, and every single song has exactly 1 rating, and we're going to collapse those into a single song with all of those ratings in it. So if we have duplicate songs, if I have this song in this list twice with 2 different song ratings, then in my output map, that should map the YouTube ID of that song to an instance of a song with the same title artist YouTube ID, but with all of the ratings. But with all of the ratings from this list. So for example, if I have, my list is something like this. I put that comma in the wrong spot, didn't I? Did I? What did I do? Oh, I had that highlighted. And this was like 4, 4, 4. Then this, I would expect to have four in any order. So we're taking those duplicates and squashing them into a single song. So my output map here, I would expect to be the YouTube ID of this song mapped to a song with the correct values here, and all of the ratings collected from every single time the song appeared in the input list. One, I guess, mistake, I'm hesitant to even call this a mistake I've been seeing about this, is don't call your task 2 code in this test, in this, testing this method. You should hard code your list with your test cases and then test your code that way. Don't call your task 2 code, because your task 2 code takes a file name, and you have no guarantee that that file name exists on the Autolab server. Now, the files from the handout do exist on the server, so you could technically, theoretically, get away with that and use those. But with the students I saw that had issues with that in Autolab, they were modifying the files, creating their own test cases through different files with different content, and then submitting that to Autolab. Autolab's reading that same file. The file exists, so there's no error. It's reading the file, but that file has different content than the file that they used for testing. And then in Autolab, they get the very scary, your test failed your own code, and then you run it in Autolab, you hit go, and it says it passes your own code, and you're like, what the hell is going on? It's almost always because you changed some data file. We see that in LO1 with Pale Blue Dot quite a bit too. If anybody modifies that cities.csv in any way, you would see that same thing. You can't modify the data and then submit. And that's the exact reason why there's no required testing in task 2, because that just causes so many problems. People want to change the data files, do their own files for custom testing, which I encourage, but then how do you submit to Autolab, and how do I test your tests? Well, the answer is create all the files you want and go nuts with your testing, and then I just won't even bother in Autolab checking your tests, because there's just so many issues that come from it. So don't read your files in task 3 testing. Write your list out. Get your expected value for your map, which will be the same songs with their YouTube ID as keys, and all of the ratings collected, all the duplicates removed. So this map will only contain each song exactly once with all of the ratings from the input list. And then check to make sure that that's what we want it to be. Call song list to map, get your actual value. And then I like another helper method here, a method that's going to compare 2 maps of songs to make sure that we have all the same information in these 2 maps. So for compare song maps, let's go back up to the top. Compare songs maps. For this, again, first thing, I'm always going to check when I'm comparing 2 data structures, are they the same size? If they're not the same size, we're done. Like, they don't contain the same information if they're not even the same size. And if I don't check that, I might get an index out of bounds error or a key not found error in this case because we have maps. We might get those errors, and then you get errors in Autolab or errors when you're testing your code instead of tests properly failing because they found something that was inaccurate. I'm always going to check the size first. And then your goal, do these maps contain all of the same keys? And do these maps contain the same value at each key? So if I have a key that's a YouTube ID for a particular song, it exists in both maps. I'm going to get the song that's mapped to in both the maps. I got 2 songs to compare. And I already have a method that compares songs. So I'm going to throw those in my compare songs method. And then let that method that I already wrote for my earlier testing do the work for me there. Can you use add rating in song list to map? Yes, but I'm not sure how that would help you. Oh no, add rating in your code. You mean in your tests? I don't know how that would help you. In your code, absolutely. That's the idea of your code is that you write the add ratings methods so you can use them in the song list to map. That's 100% the intent. So you're not rewriting that functionality. You should absolutely call it. No, Autolab will not. Autolab uses the data files that are in Autolab. One of the first things the grader does is delete all non-Scala files in your submission. So any data files that you do submit, they'll be wiped out. Even if it didn't do that, your code is going to be in a different directory than all of the other testing code. So you can't mess with the grader. Or else you would upload your own files that could possibly be blank files, and then your test could just look for empty lists and empty maps, and we're not going to allow that. We're not going to play those games. So either way, you're not getting your own data in Autolab. Someday maybe, but it'll take quite a bit of restructuring of the grader to allow that. And I'm sure, I've never had somebody come up to me and be like, man, I really wish Autolab was testing my Task 2 tests. Like, this is crazy. Why aren't you hounding me on this one? So I don't see it as a big problem either. I would much rather just give you full freedom on how to test at least one task and the application objective, this homework. I'll give you a few where you have full freedom of how to test your own code without me being overbearing with Autolab and being like, you will test this stuff, you'll test that stuff. Because after this course, that's what it's going to be like. You're going to design your own tests in completely your own way and do as much or as little testing as possible, or as you would like to do, which unfortunately most students choose 0, and then they just bash their heads against the homeworks and spend tens of hours on every single homework. Because I maintain testing will save you a ton of time, but unfortunately after 116, I realize students don't test. But you definitely should. If you write your tests, you might have more free time. In 220, 250, I'm saying. Yeah, I wish Autolab would grade all my tests. Man, I wrote my code, I tested it, it's working, I submitted to Autolab, and it gave me credit right away without having to figure out your stupid incorrect solution. Nah, this is the worst. I've never had somebody say that. Never. So I don't see it as a big problem. Am I going to go over tests for the AO? It's confusing me even after office hours. I can talk about it a little bit. Sure. Are suites similar to fun suites available for other languages we'll use, like 220, 250? Yeah, you can always use, there are testing libraries in any language. 250, you're going to use Scala, so you have Scala tests and everything we're doing here. 220 is in C. You're going to have less options available to you. But you can always, in a pinch, I don't really recommend this, use a framework, but in a pinch you can write a main method that calls your code and then checks if this equals this, do your test case. If it doesn't equal what I expect it to, then print something to the screen that gets my attention, says your test failed. Don't print to the screen and just manually verify everything that's printed to the screen, but do your checks, write your compare doubles and all that stuff, and then print something to the screen that says this test passed, this test failed. You can kind of build your own testing framework that way in a pinch. Ethan will show you the manual way to test in C, which is probably similar to what I just said. Testing the application objective. One thing I've noticed students missing, and I have my method stubbed out, so I need to test this method, but I haven't written the code yet. I like writing my tests first. I mean, I did, obviously, my solutions, but I don't feel like tiptoeing around my code like I did last time. So I removed it here. But I like having this with just a stubbed out, what we call a stubbed out method. It's a method with the right inputs and outputs and name, but it doesn't do anything. So when you want to write your tests first, write these stubs just so you don't have errors in your tests. Or else you'll have error, method doesn't exist, whatever. But what a lot of students miss for the AO, what I haven't drawn too much attention to, is that you have a song incubator method right here. So use this song incubator. You wrote a song cost function, so you have all the setup for using songs, the type of T equals song, in your genetic algorithm. You have everything set up. The number of genes is 1 for songs. The incubator is expecting a list of size 1. In fact, I just accessed the head directly. I don't even check the length. So if you give it a longer length, I'm only using 1 gene anyway. So genes, number of genes 1. You have your cost function. You have your incubator. What's the other parameter? Or is it just those? Incubator, cost function. Yeah, it is just those 3. It used to be 4, but there used to be like a sample list of genes, I think. But I guess I trimmed that down. So you can test your genetic algorithm on songs. You have everything set up for that. The expected song to be outputted is the song with the least cost. You have a top K method, which can return that for you pretty straightforwardly. Call top K with the inverse of your cost function, or the negation of your cost function would work as well. Anything to reverse the list. And that will tell you what the top song is. That's your expected return value from the genetic algorithm. Run your genetic algorithm with the cost function and the incubator and see if you get that song. So that's your first test case. The other one I recommend is setting this up with kind of like what we saw in the last lecture, a guess the number thing. You have a hidden number, which is hidden in a cost function. And that's your cost function for this. Create a class that just has one state variable, which is a double, and an incubator, which will create a new instance of that class with a list of genes equal to 1, a length equal to 1. And the gene is directly the double for that object, for objects of that type. So you're basically playing guess the number. You just have one hidden double, a cost function that returns a cost, which is how far away the input is from the hidden number. And then you want to minimize the cost, which would be guessing exactly the hidden number. And you can set up test cases for that. That's exactly what the test case number 3 for the application objective does. And then test case number 4 is exactly that, except the class has 2 doubles instead of 1, and you have to guess them simultaneously. So setting up those test cases, I won't give too much guidance with the code of that, beyond what I just said. I kind of said it all anyway. But that would be the way to test your genetic algorithm. You have it set up for songs already. Set it up for doubles. And if you're passing both of those, there's no reason for you to not be passing in Autolab. A reminder that you only need 2 of the 4 tests for the application objective. So if you get songs and 1 double, and you don't pass the 2 doubles in the playlists, then you're still good. I also have a playlist incubator here. If you want to write a cost function for playlist to be able to determine what is a good playlist, write a cost function to say what a good playlist is to you, and then set up your genetic algorithm to do playlists as well. I used to require you to write a playlist cost function. I don't do that anymore. But when I did, it was if there are any duplicate songs in the playlist, it should have a ridiculously high score. The average of the Bayesian average of each song should be maximized, and the variance of the energy levels should be maximized as well, which we don't really have the setup to do in our code here. I used to make you write standard deviation so you could write that, but we kind of cut a lot of that. So that's what I used for it. You would get a lot of good songs with no duplicates in the playlist and a nice variety of energy levels. So you would get a variety of music with all good songs. But any playlist or any incubator, any cost function you want will work. If you just minimize the, just sum up the cost of all the songs in the playlist, that works. Your best playlist is just the top song filling up your entire playlist. So it's not super interesting, but it'll serve the purpose of testing your genetic algorithm. And then you can add that little bit of logic to remove duplicates, and then you should get your top K playlist. Again, not too interesting because you already wrote top K. But if you do the energy variance, then it gets more interesting. You kind of need the genetic algorithm or write a lot of math to figure out the best playlist if you're maximizing variance of the energy levels. All right. If there are looks like there are no other questions, no specific questions about that, then we'll just move on. All right, so what we want to do the rest of the day, I know I said last time that I was going to do one big recursion example, but then I forgot that I wanted to leak test cases, so we don't have time for a huge one. But I'll do a few more little ones. At least one of these we should be able to get through. So I want to close a whole bunch of these, close other tabs, get my 2 files open, and get rid of this. So what I want to do is write, ideally 2 methods. Hopefully we can get through both of these. I want to write one method that's going to take the sum of all the values of an array of ints, and another value contains, does this array of ints contain that value? True or false? So I have my stubbed out methods here, and I'm ready to write some tests. I'll do a little bit of writing tests just because I haven't done much live test writing in lecture. So let's set this up. I have a little bit of setup. My map, I like to set up a map when it makes sense to do so. A map of inputs to outputs, to expected outputs. And then I'm going to have a loop for input to expected output in test cases. Call the method, which is array examples dot sum of input val actual equals, and that's an int, and then assert, these are ints, so I don't have to worry about compare doubles or any of that. Assert that actual equals expected. So that's my setup for my tests, and now I just want to think of more test cases. I have a couple of test cases here, and we want to write some more. We want to really test this thing. With something like this, if you have this for test cases, and you say, what's wrong with my testing? My testing is failing Autolab. The common feedback for myself and the TAs is, you need more testing. But I want to clarify what we mean by that a little bit, because there's always a misconception about this. More testing, what some students will do is this. Then they'll do like 5, 25, 1, 21. Maybe we'll delete 1, 15. We'll add 2, 22. Delete a couple of them, 10. Just a single 5. Actually, that defeats my point I want to make. 11, 10, I guess. 30, and hell, let's do 20, 40. I have more tests now. I did what the professor and TA said, feeling good about it. But what's the problem with this?
Wait.
What?
That just now. Spacing fixing.
Oh. I forget what it is on Windows, but Option Command L on Mac. Yeah, the auto format all my code. I love it. I just write sloppy code all day and then just auto format. Love it. So the problem is I did write more testing. I have more tests. But like, yeah, all these tests are testing the same thing. So if I get any one of these tests correct, if I have code that gets any one of these tests correct, it's almost certainly going to get all of these tests correct because they're all testing effectively the same thing. Lists of size like 2 to 5, all positive integers, no zeros. Like there's no variety in these test cases. When we're writing test cases, it's all about the variety. We want lots of different test cases. So this is more testing. Technically, you have more test cases, but you didn't really test your code more. The goal with testing is to really put your code to the test. Really challenge your code and say, can you get this one? And then think of a test case like, oh, this one's really going to trick my code. Can you do this? That's what we want to do. We want to really test our code. So let's write some test cases that are different test cases. I want an array of size 1 is a different test case. I always want my empty array. And with the empty array, we have to think about what should be returned. Usually this will be defined in the homework doc itself. Since this is just a lecture example, we get to just make it up. And I think it makes the most sense to do 0. An empty array the sum of ints in an empty array should be 0. Makes sense to me. It's the additive identity. Let's do that. I want my array with negative values. That's something that potentially, I could conceive of code that would be fine on positive values, but not on negative values. It'd be a little hard to mess up. Like this, for this specific example, we're probably going to do fine there. Negatives and positives are handled the same way. So I'll probably be OK there. I want an array containing only 0. And let me do one more since I thought of it. I want 0, 0, 0, and just a bunch of zeros. I'm going to use my auto format too. A bunch of zeros should sum up to 0. So now these last test cases, we have a nice variety of things that we're testing. And we could get rid of most of these ones from before and just collapse that down to a single test case. They're all testing the same thing. But now in not too many test cases, it's not all about just writing as many test cases as you can, though it doesn't hurt to have more test cases. Like it doesn't hurt to have these extra ones, and I'll leave them in there. But it doesn't necessarily help either. You want a nice variety of test cases that's really going to put your code to the test. Especially this one. This is the most important test case for this one. How do you handle this situation? We saw this a lot in homework too. Like when you're hitting those state transitions in different ways, is it always going to give you the correct behavior in every situation? If I fire up this self-checkout machine and the first button I hit is checkout, like is that going to work? Is that going to break anything? Those things like that really put the code to the test and see if it's going to work. Anyway, that's enough about test cases. Let's run this. We'll see it fail miserably. Once it compiles, Emacs shortcuts better. I don't have time to learn all the Emacs shortcuts, though. I know people who learn Emacs love it. I ain't got time for that. But Jesse, it saves you so much time in the long run. Shut up. There's nothing wrong with it, by the way. If people love their Emacs, and I'm not messing with that. They get adamant about it. Not for me. I like my IDEs. But most IDEs, I believe IntelliJ included, you can import Emacs key bindings. So if you are about that lifestyle, you can still do that in your IDE. So let's compute the sum. Okay, we're done, right? Let's run our tests. Hey, our test pass. All right. Okay. So we can't just do it that way. That's why this makes a terrible task question on homework, because you're just going to find that you can do that, and then it's super easy. The average method, the very first method you write, don't overthink that one. That one's pretty straightforward. You can do .sum. That's something I showed in lecture. .length helps you out there. Of course, map to get a list of doubles. Don't overthink that one. Of course, actually, everybody's past that anyway. What am I talking about? We're on We're on task 3 by now. But let's write this using some recursion so we can get some practice with recursion. So I'm going to start by thinking about what my base case is. As usual, for data structures, is this thing empty? Oh, wait. I'm doing this with arrays for a reason, so I can't do is empty. Oops. So for this, I'm going to want a helper method, because I'm not going to mess with this array. What I want to do is read the values of this array one at a time. So I want to get a helper method here. Which is going to take an array of ints and an int, which is going to be the index that I'm currently looking at, and also an int to return. And I want to move through this array one index at a time and keep track of the sum of values as I go through the indices. So my sum method is going to return some helper of data, and I'm going to start at index 0. So I'm going to write a helper method to be able to change the parameters to what I want going through this array. Because like with a list, we would use drop 1 and just keep removing elements from the list as we go down. With an array, we don't quite have the same tools available to us. We could kind of do that, but it's really expensive. We don't get the same efficiency that we do with linked lists here. So we're going to leave the array alone, just leave that in memory, and use our random access to be able to get each element one at a time. So my base case now that I'm ready to write it, I want to check the length of this array and see if I'm at the end of it. If index is equal to the length of the array, then I must have reached the end of the array. I can't access the data.length element of the array because that's out of bounds. So I want to make sure I'm not reading this element, but I do want to return something. Let me just return 0. We won't do tail recursion here. Let me just return 0. I have an empty array, an array of size 0. What am I thinking of? I've reached the end of the array. So if I have an array of size 0, for example, my base case, my trivial solution is this array is empty and I'm starting index 0. 0 is equal to data.length, so return 0. I have an empty array. I have no information, an array of length 0. I'm done. If I've reached the end of the array, so if the length is non-zero and index is up to that length, I'm going to return 0. There's nothing left to sum. And then I'll sum when I'm going back up the recursion. So my goal with the recursion is to use recursion. I'm not going to modify my data structure in the recursive calls, but what I want to do is process one element and then increment my index by 1. Move on to the next element. So I'm going to process one element of this data structure, of this array, and then make a recursive call. It's going to look at the next element of the data structure. If this returns the sum of all the elements from index plus 1 to the end of the array, then I need to add data of index to that. Bless you. And that should give me my answer. And we pass our tests. So we're making our recursive call. We get closer to the base case. Our base case is we've reached the end of the array. And our recursive calls are going to sum everything in this array from this index onward. So if we're at the end of the array, there's nothing left to sum up. We're just going to return 0. If we're not at the end of the array, we're going to make a recursive call that sums up everything from index plus 1 to the end, and then add the value at index. And then if I make my initial call to say sum up everything in this array from index 0 to the end, well, this should return all of the information. Let me catch up on chat a little bit. We'll do the next one, or I'll rewrite this with tail recursion. But I want to do the lecture question a little early, so I stopped doing it right at the end. The next example will show this more, but recursion can have more than one base case. Everyone hear that? Yay. We can have more than one base case. In class, we've never gone over memory diagrams for first-order functions, storing functions as variables, or using functions as parameters, return types. There's one example of such memory diagram in the memory diagram reference. Should we know how to do this? No. First-order functions will not be on the quiz for the LO3 quiz. That's why I never showed it in lecture. I don't want to do it. I don't want to make you do it. They're painful. They suck. They don't help your understanding of how first-order functions work. We're just not going to do them on memory diagrams or quizzes. Paul did the one in the memory diagram reference, and he's like, I hate this. And we talked about it for a while, and we both agreed. It doesn't help your learning or understanding of how a computer works at all. Are Scala functions on the heap? Yes. Scala functions are on the heap, not Scala methods. Scala methods, to be honest, I don't know where they live. They might be on the heap. I don't know. But functions, like if we declare a variable of a type function, like effectively a function pointer in C++, then that will be on the heap. But it gets fuzzy as to exactly how it's on the heap. I don't fully understand it, which is part of why we're not going to make you do it. You almost forgot Scala was a garbage language. Scala's fine. Scala's fine. Scala's better than Java, I'll say that much. All right, I don't know if I want to write this tail recursive. You know what? Let me do a tail recursive just without much commentary, just so I can say I did it. Total 0. We have our accumulator. We're going to just return it here. Then our accumulator is total plus. Oops, that's not right. Data of index. So there's our tail recursive. We got our tail recursive marker. Let's run it, make sure it works. And it works. You know what? Maybe I should have spent more time on that because I don't know if I want to. I don't know if I really have time to do what I wanted to do here. You know what? I think we do. So let's set up our test cases for contains. And for this, even if we don't get to the code, or do we do the code first? That sends a bad thing. Contains. We have a situation where I want 3 values here. I want an array of ints, the int that we're trying to find in that array, the one that we're checking if it contains, and also if it should contain it or not, the expected answer. So we want 3 values out of this. We can only really get 2 in a map. So whenever we have these situations, what I do, what I recommend you do, which you can do, what are we testing? Contains case. I'm going to make this a list of contains test cases, we'll call it. Is going to equal a list. And what we can do is create a helper class which is going to take the 3 values that we want. So I want an array of ints as the input. Now we're going to have as many values as I want for my test cases. An array of ints as my input, some value that we're trying to find, and expected, I'll just call it expected, which is the Boolean whether we expect to find it or not. And that's it. That's my entire class. I'm not even going to give this class a body. You know, we could. Actually, do we have to? Is that what my errors are here? No. I'm not even going to give this class a body. I just have 3 values that I want to do, that I want to use. This could technically be a case class, but I'm not talking about those. And then we create our list, which is going to be, actually I want to keep some of this, new contains test case, and then the values that I want. To find false, 6 is not in that list. And then just come up with my test cases like this. Can clean things up quite a bit doing this. To find 2 is true. What if we have the same value multiple times? That's definitely true. -2, false. And I won't belabor the test cases here, but empty array, we want an input like that, is false. Let's do one more just for good measure. -20, -20. Make sure we can find a value when it's the only value in the array. Now when we iterate over these things,
Work on this.
test case, actual, test case, oops, test case dot input. Come on. Test case. It's a list of things. Declaration is never used. I'm trying to use it. Trying. Test case dot input. Is it just going to let me do this? What am I missing here? Test case dot data. This might just be how it ends. We might just crash and burn right here.
Yeah, that's what I'm saying.
Test case. Oh, I know. Bail. Test case dot data. Test case dot to find. Assert. Test case dot expected. So that's how we would set that up. Obviously, we're out of time here, so no time to write the recursion. But it would have been spectacular. So have fun, and I'll see everyone Monday. Is it Friday? Yeah, have a great weekend. See everyone Monday.